Last time I left you with a warning. Put multiple agent loops in a room and they fail like organizations, not like programs. Here is what that looks like. Agent A finishes a task and hands it to agent B. B doesn't love the output, kicks it back. A revises, hands it back to B again. B still doesn't love it, hands it to C for a second opinion. C disagrees with both of them and hands it back to A. Nobody owns the task, nobody has the final say. Practitioners call this the infinite handoff loop, and it can burn real money in minutes with zero output to show for it. That's today's focus. Now, how to split work across agents and dispatch it in parallel, we covered that last time. It's what happens after, when that work has to be merged, contested, or reconciled by something that isn't a program flowchart anymore. It's a management problem. Let's get into it. Okay, here is the thing that trips people up. A sub-agent inside one loop and a second independent agent are not the same problem. Inside a single loop, spinning off a sub-agent is about noise reduction. You keep messy exploration out of the lead context and get back to a clean summary. That's solved territory. Multi-agent introduces something new. Ownership. Who is responsible for which piece of the task? Who has right access to which resource? Who gets final say when two agents produce conflicting answers? That's a routing and arbitration problem, not a context hygiene problem. And it doesn't go away just because each agent has a clean, isolated context. You can have perfect isolation and still get two agents confidently overwriting each other's work. Isolation was never what kept them in sync. Division of labor sounds simple on a whiteboard. In practice, somebody, a person, or an orchestration has to decide the boundaries before agents start working, not after they collide. The dominant pattern right now is orchestrator-worker. A lead agent breaks a task down, delegates pieces to sub-agents, and synthesizes what comes back. Anthropic built exactly this for their multi-agent research system, and in their own engineering write-up, they are upfront about the cost. An orchestrator running sub-agents uses roughly 4 times the token of one chat agent, a full pipeline end-to-end closer to 15 times. And here is the number that should give you a pause. In Anthropic internal evaluation, token usage alone explained about 80% of the variance in performance. Not smarter coordination, just more compute. So real talk, before you reach for multiple agents, know what you're buying. Not intelligence, tokens plus the orchestrator's synthesis step on top. Because someone has to read everything that comes back and decide what's true. The levers that actually control cost. Cap tokens per worker, kill agents that stall or duplicate another work, and put your expensive model on the orchestrator's synthesis, not every worker. So if the agents need to talk to each other, how do they actually do it? Two shapes dominate. One, direct agent-to-agent messaging is getting a standard. Google's A2A, agent to agent, now stewarded by the Linux Foundation, which as of April 2026 reported over 150 supporting organizations and SDKs in 5 languages. The framing that matters. MCP is agent to tool. A2A is agent to agent as a peer. Complementary layers, not competitors. The other shape is blackboard pattern, also called event-driven coordination. Instead of agents messaging each other directly, they read and write to a shared workspace. Decoupled so you can add or remove specialist agents without rewiring anyone. The known failure mode. Two agents write to the same board entry at the same moment and you get a write conflict. The fix practitioners converge on optimistic locking or a queue layer like Redis or RabbitMQ in front of the board. Here is where it gets important to internalize. These failures don't exist in a single agent loop at all. There is a taxonomy for this now, MAST, and it splits multi-agent failures 3 ways. About 42% are specification problems, unclear task boundaries. 37% are coordination failures, duplicated work, contradicting outputs. 21% are verification gaps, nobody checked the final result. The contradicting outputs failure is the one to picture concretely. A support agent approves a customer's refund, while a compliance agent working the same request in parallel blocks it. Same request, 2 contradictory outcomes, and depending on your system, both can reach the user. And that infinite handoff loop from the top of the video, that's a coordination failure at its purest. Nobody holds the ground truth, so nobody can end the disagreement. Notice what doesn't fix it. An iteration cap, a token budget, a termination stack, the exact guardrails from a few videos ago. Each agent is behaving fine on its own. The fix here isn't a better budget, it's giving somebody a final say. Now, the honest counterpoint, because this space has some real skeptics with data. Cognition, the team behind Devin, wrote a whole piece called Don't Build Multi Agents. Their example, splitting a Flappy Bird build across sub agents produce an incoherent result. One agent built a Mario style background, another built a mismatched bird because nobody was holding the aesthetic vision. Coordination broke something a single agent would have kept consistent. They partially walked this back by April 2026. Multi agent works, they said, when writes stay single threaded, even if multiple agents are contributing intelligence. The academic data backs this up hard. A Stanford study normalized for token budget and found that once you control for how much thinking each side actually gets, single agent systems match or beat multi agent ones on multi hop reasoning. The multi agent tax was inflated compute, not smarter coordination. The pattern underneath it all. On genuinely parallelizable work, multi-agent coordination gave an 81% improvement in benchmarks. On sequential dependent work, it caused up to 70% degradation. The whole rule in one line. Orchestration only helps when the subtasks don't depend on each other. Here is the tax nobody puts in the pitch deck. Debugging compounds across agents. Non-determinism means identical inputs can take different paths run to run, and a bug introduced at turn 3 can surface as garbage at turn 8, with a downstream agent treating a hallucinated fact as ground truth and building on top of it. There is a latency cost too. One documented case study clocked a single handoff eating 5.93 seconds out of 13.93 total, a 45% coordination tax before any real work happened. Chain a few of those and you have killed real-time responsiveness. You will also see claims that 40% of pilots fail within 6 months gains flattening past 4 agents. Even that failure rate number is shaky, treat it as directional, not gospel. So here is the heuristic. Reach for multi-agent when the subtasks are genuinely independent and the coordination overhead is smaller than the parallelism you're buying. Stay single agent when the work is sequential, when one owner needs the final write, or when you haven't measured a real bottleneck yet. Default to one agent, earn your way to more. So land the frame. A single loop fails like a program. Bad input, bad output, deterministic enough to trace. A multi-agent system fails like an organization. Miscommunication, duplicated effort, nobody accountable for the final call, components that all technically did their job. You debug it less like a stack trace, more like a post-mortem on a team. Practically, the tooling is catching up. AutoGen is now folded into Microsoft's agent framework as of April 2026, and LangGraph now ships an official supervisor package built for exactly this pattern. Different frameworks, same lesson. Somebody has to hold ground truth. That's multi-agent orchestration. Dispatch is easy, coordination is the whole game. Subscribe if this saved you from shipping a 5-agent system for a job that one agent could have done. See you in the next one.